My name is Stafford Vigors. I'm an assistant professor in the School of Agricultural Food Science. It's been a huge research area of trying to find various feed additives and different compounds that can actually alter the microbiome and reduce methane emissions. So these include things like seaweed extracts, different seaweeds, fats, probiotics, prebiotics, amongst many others. Some of the best performing additives have been able to reduce methane by over 90%. We're one of the feed additives that is closest to market and being used most widely, reducing methane on average by 30%. So I think by changing the microbiome, we're either altering the digestion of the diet or changing the pathways that are actually leading then to the production of methane. So depending on the additive type will depend then on the mode of action and how we're actually getting to that reduction in methane. So yes, this has been one of the issues around any of the kind of products that have been tested up until this point is the long-term reduction of methane. So one of the issues that people are finding is that we add in these diets, the microbiome when it's in the adult animal is quite resilient, so it tends to then to return to a state before the additive was actually delivered. So one of the areas that we're looking at is trying to alter the microbiome or the composition of the stomach of the cow or the other ruminants in early life. So can we then make that change which will last through the lifetime of the animal? So one of the other areas we're potentially looking at is can we feed an additive to the dam to then alter the microbiome of the progeny when it's actually born or during that early life period. It's still quite in its early stages, so I know there's one company that has a patent about the use of a feed additive in early life, but there is still a lot of other research that needs to take place. So as I mentioned previously, we need to look at kind of overall effects, not just focusing on say methane emissions. We need to look at productivity, future fertility of the animal health. So there's much more detailed and larger studies that need to take place until that is a viable option. But the early preliminary data is promising that it is a potential solution. That's the I suppose, second approach to trying to reduce methane emissions is trying to breed animals that inherently produce less methane than animals that actually haven't been selected for that trait. So New Zealand have been the world leaders of focusing on this, so they are quite far down the line on sheep populations, so they're projecting that they can annually reduce methane emissions by 1% for breeding for low methane emitting sheep. So that is, I suppose, proof of concept that can then be applied to beef animals and also then to dairy cattle. So I know, for example, in an Irish context, in Grange, they've worked on projects focusing on breeding beef animals for lower methane emissions. So it seems to be a viable option also.